now recording. And now I've lost, I can't see anything here because of the sunlight. Okay. So, I hope you guys are doing well. I think we talked about there yesterday if you wanted this to be your main screen. Did someone say you have to lock me as the main or something like that? If anybody wants to add anything, feel free to turn your mic on and add. But this is where we're going to be there today. Quiz 3 will come out there this afternoon sometime. And it's a good one. It's 20 questions. Okay, it's not a 10 question quiz. It's a smackdown because I want to expose you guys to what is coming there next week. You guys know what's coming there next week. Every single question I've ever given you is an exam question. I'm just going to change the numbers. Okay? And I think you guys are doing really great. I've received some... I think the quiz is due... You have a week to do it, right? I think it's due before next week's class. Check, it's written right on there. Okay? Okay, perfect. And so you got a week to do it. I'm going to recap what we said there yesterday because some people were not here at the meeting there yesterday. The general consensus was that I and you didn't like the emailed, remember that quiz 1? So we'll just forget about that. We'll just forget about that. The general consensus is that the current system seems to be working, where what I will do is there will be a paper, like it'll look exactly the same as it is for quiz 3 right now. Quiz 3 and quiz 2, you go into the folder and there's 2 folders in there. There's a paper copy folder for those of you guys who want to print off a paper copy, or for people who don't have printers, you'll have a Word document that you can input answers into there. So you have your paper copy. I want people there to, if paper's your thing, you need a paper copy. There you go. You work on it all week. When you're finished working on your questions, then you will go to the answer portal that's in the same folder. And it's just an e-copy of the test that you just had a paper copy of, and you just bang, 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 bang. Okay, you should be able to stop it and start it and all this, but my recommendations, get the paper copy, save that there to your desktop, work on that there for 3, 4, 5 days or whatever, and then when you're ready to go, upload your answers onto the e-portal. That's what I'm thinking there. The test will be next week. Questions I got there yesterday, of course. Ian, how many questions is it going to be? And I don't know, I'm still kind of working on it. I want to put some true and false because I like true and false. That's it. All right. I'm gonna try and put on some definitions. We'll see how it all goes on the e-copy. It's easy enough to put it on a paper copy, but I'm gonna see if I can do that there for the e-copy, the answers. Oh, what do we got here? Sorry, man, cut out. How many days do we have to work on the paper copy? The test is not going to be days. You will not have days to work on it. You'll probably have 12 hours. That's what I'm thinking. Okay? And if there's any issues, let me know. But what I'm thinking there is that the test will open at 1 and it'll close at 1. And what that'll do, it'll give people who have to work, you can get your work done. Okay? If you got kids, like I do, like we just had a bit of a crazy morning there. I did a class there this morning, and my family was downstairs, and the dog ripped its nail out. It's not time. There will be a time. So my wife is off to the vet right now. It's hectic. There's kids. So I want to accommodate for life, okay? Because I'm not spared. I'm affected, and yesterday there we had my son come on in and all that. It'll probably happen again there today. So, but it's not going to be like a 3-hour time test. Okay, the test will be open for 12 hours. That's what I'm thinking as of right now. Okay, you will have a certain amount of time to do it. Your e-copy, you can stop and start and do whatever you want. but at whatever the end of the time is, everything closes. So you've got to make sure that everything gets in there. But that should be more than enough time. It should be like 50, 60, 40 questions somewhere in there. And no different than what you're going to see on your quiz there this afternoon. No different than what you saw on your quiz there last time. So that's what's going to go on there for the test. There's the quiz. Have a look at the quiz. The quiz is a good one. It's a doozy. And that's why I like quizzes. Quizzes are worth 3%. And, you know, bomb a quiz, don't bomb a test. And I've been doing this there for years, and when it comes to quizzes, you always have a quiz before the test. The quiz is worth 3%. And if you think that, 80% is a good mark, 60%, it's not a good mark. But on a quiz situation where the quiz is only worth 3 term marks, if you get 80% on a quiz, you get 2.4 term marks for your final grade. If you get 60% on a quiz, bad mark, you get 1.8 term marks. 1.8 term marks to 2.4 term marks. You're thinking, okay, there's not really a lot. Statistically, they're no different. Because at the end of the day, I round up anyway when I input your final mark in. Again, what the questions on the first and second. Sorry, Michaela, I missed that. I'm going to keep my chat section open here. Okay, so yeah. So both the paper copy and the answer portal will open at the same time. They will both close at the same time. So you will not have days or anything like that. You're going to have to get motoring on it whenever you get a chance. Okay, and make sure that those answers are uploaded before the time allotted. There's not a time. You'll have it's not going to be timed like a 3-hour. Okay, it's going to be open for the time, and when it closes, that's it. Okay. Will the questions on the first and second quiz be similar to the 10th? Everything is fair game. Oh yeah, you guys have got your quiz 1, quiz 2. What is happening, man? The whole world is just going mayhem. Alarms going off, dogs breaking their nails. It's mayhem. Now I even forget what I was talking about. Can anybody remind me? Anybody? Can you hear me? But anyway, you guys will have lots of time. Have a look at your quiz 1, quiz 2, quiz 3, your assignment, and the labs. Okay, all of that knowledge there. It's basically what I'm going to do is going to be true and false. It's going to be matching answer with the definition. I'm going to try and do that. We'll see how I'm currently working on it. And multiple choice. That's what we're looking at. Okay. One of the advantages there of being able to print off or have a copy of your paper copy is you can start banging off easy questions. Bang, 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 bang. All questions are going to be worth 1 mark. Okay. There are going to be some questions there that'll take you 5 or 6 minutes to do. Promise you. And we'll tackle them there today. There's one of them on their quiz. Oh yeah, man, it's a pain in the backside. It's worth 1 mark. You're going to have to judge this. Okay? Get the easy ones done first. Hit the other ones last. Okay? Maximize your time. Any more questions? Talk to me. It's open mic for a minute or 2. Or 3. Okay, good enough. What I'm going to do now is, hopefully you guys have had a chance to look over the PowerPoint. And I'm just going to pull that PowerPoint up. And where is that? Georgian stuff right here. Week 6. No, we got that. Okay. So I've got this PowerPoint here. All right. And I'm going to screen share if I can. Yeah. Yeah. Oh, yeah. We've got all this time here for calculation. That's all we're doing. Okay. We're just doing calculations. That's why I got my little board up here. So, but you see, I made this there a couple years ago there just to help you guys out, just to get your brain going. Okay? And connect the dots using only 4 straight lines. Have a look at that. If you can't figure out the answer, let me know. There's this one here. Basically, it's a rectangle with the corner snipped off. Okay? And all the information you get is you are allowed to place one straight line of any size onto this shape. Okay, I know it looks like it's folded, but it's not folded. It's just a rectangle with the corner cut. And you're allowed one straight line of any size onto this shape, and at the end of it all, you get 2 triangles. Think about it. Let me know what you come up with. What is the pH of 0.001 molar hydrochloric acid solution? Okay? So, what is the pH? So what do? First thing you do, you go to your formula sheet. pH. Sorry, maybe let me know if you guys can't see or if there's a problem. I've tried to do my best here to get something here. But pH is equal to the negative log of H plus. Okay. Now this one here, I didn't give you the concentration of this. Okay. Is everything okay? Sorry, I guess I need to ask. I'm screen sharing, but can you guys still get this if you guys on the big screen? Is everything okay?
I put it in a full screen mode, and I just made your camera a little bigger so I can see what you have on your whiteboard. But it won't come through on the recording, just so you know.
It won't come through on the recording, eh? Interesting.
Whatever is on your screen is what will be recorded. So whatever you see is what we'll get.
All right. Okay. All right. So then what I will do is, now, is that better? Can you guys see it like that? Can you guys lock screen?
Yeah.
Okay.
I can see it better. It's a little pixelated on my end, but I can read it.
All right. Well, maybe it'll turn out better on the when I make the video and post it there to YouTube. And so this is there for the first question from the PowerPoint. Okay. And whenever you see a strong acid, you remember these guys here are going to be 100% dissociation. And there's a couple of them there that I want you guys to know. And in this very first question there in the PowerPoint, I gave you a concentration of hydrochloric acid. Because this is a strong acid, the concentration of the hydrochloric acid will be the same as the H+. Okay? So whatever number that was on the PowerPoint there, that's the number there, you sub in there. But how I'm going to work this is you guys have had a chance to look at the review package. You guys have had a chance there to look at the PowerPoint there. What questions do you got? Anybody, you can type them into the, and I'll start writing them down and we can just start hitting them. Because there's your test 1 review. Okay, I have all the answers. There we go. Answers are not what you're looking for. You're looking for methodologies, because everything in here is going to be your exam. I'm just going to change the numbers. Okay, so why don't you guys tell me where you guys want to start? What question, whether it's from the PowerPoint that I provided you or the review package, and we can start getting started. I don't see any questions in there. Are there any questions there that you guys would like to try out? Give me a number, give me anything, and that's where we'll start.
Can we run through this question here?
Which one?
The one that you have like on the board.
Oh, okay. So from the PowerPoint here. So it is going to be this one here for everybody. Share. You'll see it right there. Okay, so this one right here, what is the pH? Okay, of a 0.001 molar. So this is 0.001 molar. So I'm going to stop sharing. So This question here, definitely, you'll need this formula here. But the ideology is that I will either give you the H plus concentration, and I'll state it, and you plug that in. I will either give you a strong acid concentration, and a strong acid concentration means the same thing as H plus. So whatever that number is, you will plug in here. Okay? Or what I could do is I could give you the OH concentration of a solution. Well, you can't just plug this into here because that's not what the formula says. It's only looking for hydrogen to calculate pH. Well, if I give you the hydroxide, you got to use this formula. What is it here? Sorry, I'm losing my mind here. H plus times OH minus is equal to 1.0 times 10 to the negative 14. So there's 3 different ways that I could give this question. Here I just easy peasy. Bang, bang. Strong acid, easy peasy. Bang, bang. If I give you the OH and ask you to find the pH, you got to put the OH into here so you have that value. You always have that value. You solve for this value, plug it in. That's how that question goes. So in the answer, so because this is a strong acid, I think it was 0.001 for hydrochloric acid. That's your hydrogen concentration because it breaks up 100%. So it would be pH is equal to the negative log of what? 0.001 molar. Now, I worry about calculators, I really do. And this is one of the things there that I can't really help you out on. Normally I would take half an hour of a class 1, and make sure y'all know how to operate your calculator because some of these, men, are tricky. And but negative log of 0.001. You guys get an answer of 3? Okay. So that's that one there. All right. Next question. Could you do one solving for OH? Well, here, we could try that. I'll just make this up. Find the pH when the OH minus concentration is equal to 1.54 times 10 to the negative 3. Okay? So I want you to find the pH when the OH concentration of a solution is this. Well, this number here we have to put into this formula, which will tell me a hydrogen concentration, and then you plug that in there.
Sorry, Ian, what was the number for that one? I just can't spell blurry.
1.45 times 10 to the negative 3.
Okay, thank you.
No worries. Is that better? I don't know. Darn it, man.
I think it's maybe how hard you press on the marker. Like, we can see the one where it says pH equals negative log. We'd see that really well, or I can personally. But then at the top, is it maybe you wrote a little lighter?
Right in here, find pH.
Yeah, or is it did you write
maybe maybe it's just not as thick. I'll have to all right. No, I'll
I think maybe that's just
yeah. Find. Okay. So when it comes, so this is 1.45 times 10 to the negative 3. This is for your OH. Doesn't go in this formula yet. We plug it into here. You solve for hydrogen. Okay. And this is 1.0 times 10 to the negative 14. Okay. So put this information in here. Put it, and you always have this. You solve for hydrogen, and away you go. Okay. Guaranteed you'll see that. And you know, there's lots of questions there, and go back to the review questions. and find them on the review package. Okay, try those out. And remember, please do a question twice on the review package. Do not do it a third time. If you're still getting the wrong answer for the second time, email me and I'll check it out. Okay, I've gone through these, but you never know. You never know, and I don't want you guys to waste your time. So here's your oxygen or your hydroxide. You plug this in. So let's try it. Okay. So hydrogen is equal to would you agree? Okay. So I've rearranged this formula. Now it's in terms of hydrogen. So I got 1 times 10 to the negative 14 divided by, what did I give you? 1.45 times 10 to the negative 3.
Sorry, Ian, we just can't see that, the bottom bar of everyone's thing, it's covered.
You can't see that.
There you go, perfect.
Is that okay?
Just a little bit more.
Sorry.
Okay, there we go, that's good.
Okay.
I went into full screen and I hid participants who was not sharing their video, and now I can actually see it.
Okay,
so maybe try hiding people that are not. If you're watching this and you still can't see it, maybe just go to the layout, and I go to full screen, and there's also an option there's hide participants with video off, and I did that, and I can see everything.
Excellent. So everyone try that. There's no time limit here. We'll go until I drop. Okay, so there's your hydroxide. You plug it into this formula here because it doesn't go into this formula. All right, and now remember when you're dealing with these scientific notations, okay, do not use times 10 to the hat button or whatever you got. Okay. How I put this into my calculator is I would type 1.0 EXP button 10 negative 14 divided by the button, all right, and 1.45 exponent 10, or you don't need the 10. Sorry, I'm losing my mind. Negative 3. So 1.0 exponent negative 14, that's how you would enter that number into your calculator, divided by 1.45 EXP button negative 3, and I don't know what the answer is, but let's have a look. 1 exponent negative 14 divided by 1.45 exponent negative 3. So, what do we got here now? So this is my hydrogen concentration is equal to 6.89 times 10 to the negative 12. Now, we can sub this in here. Okay? And that would be negative log answer. So my pH is equal to 11.2. Okay. And it makes sense. Look at my hydroxide concentration. Look at my hydrogen concentration. Which one is massive compared to the other one? Well, here I have 10 to the negative 3, which still seems pretty small. But here I have 10 to the negative 12. So my hydrogen is crazy small. My hydroxide is crazy big. And that makes sense. My pH is 11. This is a basic solution. Make it make sense. All right. Another question. What do we got? I hope you guys are doing well, and I hope you guys can see this because I really want you guys to do well. Another question. Review package number Slide number 2 on the... If I don't hear anything, I'll just continue on to the next slide. Or let's try and find... oh, this is a good one. Have a look here. Share. It's a good little question. What is the hydrogen ion concentration in this molar solution of hydrochloric acid? Okay. So, I'm going to erase this, but really I'm not because I'm recording. So, oh man. Huh, that was easier to come off there yesterday. Okay. So, what do we got now? How I want you guys to do this here is, I know you guys can't really see, but I'm going to start pulling things out of this question so I never have to look at it again. And HCl is equal to 0.00080 molar. So, have a look here. So what we're doing now, okay, is I don't even need the question anymore. I pulled out all of the information. And that's how I want you, every question, you never know what's coming, so you've got to reset. Because I'm going to throw at you mashed potatoes. Have a look at the quiz. I think we even go back to week 1. Okay? Just because. And you never know what's going to come. So reset every question. So now, here, I'm looking for the hydrogen ion concentration. And I've given you the molarity of this hydrochloric acid. Question is easier than you would think. Don't forget, write somewhere these type of questions, because if you have a strong acid, this number here will be the same as that one there.
Ian?
Yeah?
I'm so sorry to interrupt you again.
No.
I think when the one student, I forget who it was, when she had her bar thing at the bottom and she couldn't see very well, you moved the camera down, but now we can see what's on like the question on the top.
Oh, wonderful. No, it's okay. How's that?
Thank you so much.
All right. No, good. Hey, please don't be afraid to interrupt. You know what I mean? We're all kind of just coping here, and we'll get it done one way. So thank you for letting me know. So please, when you see a strong acid, this number here, because this thing is going to break 100% into H plus and Cl minus, all acids, strong bases do the same thing, 100% break. All right? This number here will be the same as H plus. So in this case here, for this question, H plus is equal to 8 molar. And you can calculate the pH, but that's not what the question's asking for. Okay? Good. What else we got? Are there any other questions there? Please have a look at the review package. If there's any question there that you guys want to see, this is for you. Now's your time. Talk to me. You can put it in the, okay, I've got numbers 56, 77, and 88 on the review package. 56. Okay. So hopefully there you guys have a copy or how you're able to access. Let's have a look at 56. Question, is this from the review package? Because 56 is not an acid-base conjugate. Okay, but okay. So have a look at 56. And I'll
Sorry, not 56 isn't an acid base. I just wanted, if you don't mind.
No,
that.
I will. Perfect.
Okay.
So let's have a look at it, and I'll see if I can bring it up here. Do I have your review package? I thought I turned that phone off, man. What? That's like the weirdest phone. Yeah, is it in here? Where's my review package? Okay. Test quiz. Sorry. Quiz stuff. Final test. Where is that? Test 1 review. There we go. Winter 21 final without answers. Okay. Apologize here. I'm getting her going. So let's have a look at 56. This is a good one. Good question. Okay. So if you have the review package in front of you, if you do not, you will rate now. So this is the question here. 56. This compound, COCl2, is introduced into a closed container until its concentration is 0.89 molar. What will the concentration of chlorine gas be once the reaction has reached equilibrium? Okay, so maybe I'll try a black marker here, which I, for some reason, don't have. Okay, let's have a look. How we do these questions. First of all, I write them like this, okay? Just write them out. And you see how this question is kind of laid out? That's how it'll be on the test, so that you don't have to really write this equation out. As long as you can somehow print off the test or get a hold of the test paper copy, you can just use this as your template. You don't have to write it out like me. I'm just writing this information out here so that I can eliminate the screen so that you guys can see. 7.6 times 10 to the what? -4. And what is it asking for? What will be the concentration of Cl? So here, we're looking for here. So now, and ClCl2, COCl2 is equal to 0.890 molar. Okay, so now I can remove this. And hopefully in there you guys can see what's going on. There's my equation. This is what I'm looking for. I'm looking for the concentration of this. I turned this phone off, man. Weird. Okay, you're off now. Whoa, that's tripping me out, man, because I really did turn that phone off. Anyway, here's your formula, your chemical equation. We're looking for this. It's a K question. So what are you going to have to do with these Ks? Okay, you've got to make your, you've got to flip around, right? So remember how to do this? It's product over reactants. And just to be clear, your molar ratio, 1:1:1. So KEQ is equal to products over reactants. Remember, square brackets is concentration, moles per liter. And Cl2 all over COCl2. And you see, I don't have any, well, I do have exponents, but I don't need to write them because there's only ones. Remember, if there was coefficients out front of here, then they show up as exponents, right? Okay. So here I have my equilibrium equation. And what it's saying here is it's introduced, I've given you the concentration of this guy here. So, actually here, I'll just rewrite this again as this. KEQ is equal to 0.890 molar. My KEQ, we have, I gave it to you, 7.6 times 10 to the -4. Hopefully there you guys can see that. If you guys can't, let me know. Please don't, now is not the time to be bashful. If you're not getting something, now's the time. Okay? So here I've got my KEQ plugged in. I've got this going. But how, it's asking me to find this one. Well, if you have a look at the equation here, I have one of these guys. And this thing breaks into 1 and 1. So let's say I have 8 of these guys here, and they all break. How many of these guys am I going to have? 8 and 8. So whatever happens, however many of these I have, I'm going to have exactly the same as these guys. These guys here will always be same. So therefore now, I can go X and X. Okay? Same for the KA. Okay? Exactly the same banana. So X times X...
No matter what the...
Sorry?
Sorry. So no matter what the equation is, those will always be the same, or just in this particular situation?
In this particular situation. All right? Because you've got 1 and 1. And generally, that's how these ones go. For KEQ, KA, which is the same as KB for bases. These are for weak acids, weak bases. It's the exact same process, but I'm not going to focus on KBs. I'm just going to focus on that. KEQ, KA, there's also KSP. Okay? And how it's going to go, it's basically all the different formulas there that I've given you. If there's 5 unknowns in a formula, I'll give you 4. You give me the 5th. Okay? Here, I got 1 banana, 2, 3, 4 bananas in this equation. All right? I've given you this one. I've given you this one. But here, these 2 bananas, I didn't give them to you because you can put them together and solve as one. Okay? So in this case here, now you're flipping formulas around. I'm just going to do this quickly. Let me know if you guys can't see or can see. I don't know where the bottom of the screen is. And maybe I'll just put it over here. So I'm going to, this whole formula here, I'm going to flip around. I got x squared is equal to 7.6 times 10 to the negative 4 times 0.890. You guys see that? Yes, you can. Okay, so I've taken this formula, flipped it around. Okay, so x squared will be equal to 7.6 exponent negative 4 times 0.89. So I got an answer of 6.82 times 10 to the negative 4. Now you do the square root, and the square root, you get x is equal to, square root answer, 0.026 molar, which I hope is the right answer. Yep. Okay. That is answer C. All right. So this one right here is a good one. You'll need this one there for your quiz. You'll need this one there for the test. Everything there you'll need for KA, KSP, all these things. They're all kind of the same pattern. Someone asked, are they always going to be X here? No, I could give you these numbers. I could give you this number and ask you to find me the K value. Right? So it all depends on which side of the ladder you're walking up. All right? Because the ladder looks like it's going up this way, but then if we flip it upside down, all right, you're still walking up. So it's all the same. We got another one here. How we doing? What's the other one? If you can't see, let me know. Okay? How's that one? Can I move on? What do we got here? I think we had a question. Sorry if this was said already, but where do we submit our answers for quiz 2? Quiz 2 should be in the same folder. Okay.
It said for me that please use other folder for uploading answers.
Yes. There's another folder in there that, in the same folder, you'll see it. Answer portal.
Okay, maybe I just need to refresh it.
Okay. Let's have a look here. If there's any issues, let me know. What do we got? 77. Question 77. Let's have a look here. So, what do we got here now? Aha, good. This is a good one. So, a sample of oxygen is collected over water. Whenever you see that one, ding, 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 ding. Go to your formula sheet and you'll see Dalton's law of partial pressure. I'm going to try and show that one right there. It's right there. Dalton's law of partial pressure. All right. What we do in chemistry a lot is we'll mix A and B together and a gas will be produced. But there'll be other stuff in there from the reaction that we don't want, and we want to kind of filter that gas. We only want that gas. What we do is you'll bubble it through a water filter. It's kind of like if you were smoking a shisha pipe and the smoke goes through a water bowl there, and in theory cleans it, right? This whole idea here is that when the gas goes through this water bubble, some of the water tags along with it and becomes a gas. All right? So a sample of oxygen is collected over water at 22 degrees, okay, and 762 torr. What is the partial pressure of the dry oxygen? Okay, the vapor pressure of water is 22 degrees is 19.8 torr. Now, I don't know, this this is what we're looking at. So, you got pressure total is equal to pressure of the gas you're looking for plus the pressure of the water vapor. So, in this case here, a sample of oxygen is collected at 22 degrees and 762 torr. So 760 torr. Okay, and my pressure of my, so PA plus, what is that? 19.8. Okay, so let me go back to the big screen here. So in this case here, they've given us it says there a collection of gas was collected over water and its pressure is 760 torr. The pressure of the water that is also in that mix is 19.8. How do I solve for just the pressure of the oxygen? Because right now we have a balloon with oxygen and water in it. And I only want to know the pressure of the oxygen. Well, 760 minus 19.8 equals whatever you're looking for. Those questions there are pretty easy. Okay? Those ones there should be gimmies on a test. Dalton's law of partial pressure. The pressure of the water plus the pressure of the gas, add them up, gives you the pressure of everything. All I'm looking for you to do there is subtract. Another question. 88. What do we got? Okay. Just going to share. And let's go down to 88. Now, this one here. At which pressure would 2.6 moles? And again, the trick of this is, oh my gosh, what formula am I using now? Don't worry about that. Pull the information out and then find your formula. So, what do we got here now? Let's go. Come on, stop sharing. There we go. Okay, so question 88. You guys can have a look at it on yours. At which pressure, so I'm looking for pressure. Bang. There's a start. What information did I give you? You can go knowns. Okay. Moles is equal to 2.60. Sample of gas at 20 degrees C, so I got temperature is equal to 20 degrees Celsius. And I have, oh sorry, I'm reading the wrong one. 2.6, no, that's 20. Yeah, that's right. And volume is equal to 25 liters. What do we know that we can use here? And you go through and you got pressure, volume, temperature, and moles. Hey, I'm in gases here. What's my only formula there of that pressure and gases and moles? And that is PV is equal to nRT. Okay? And you just plug and play. So we're looking for pressure. Rearrange your formula. P is equal to nRT over V. Okay? And just remember, we spoke about this there, and you have to be able to flip in and out of Celsius and Kelvin. Okay? Right here. So 20 degrees Celsius is equal to 273 Kelvin plus 20 Kelvin. A degree Celsius is equal to a degree Kelvin. They're the same, but so in this case here, this would be 298 Kelvin. If you wanted to find the Kelvin value of minus 30 degrees Celsius. So remember there, 0 degrees Celsius, and then we have 0 Kelvin. This is absolute zero. I don't know if can you guys see that? There we go. And so we have 0 degrees Celsius and 0 degrees Kelvin. Okay, so this is minus 273 degrees Celsius is equal to that. If you guys can't see that, let me know. And then I have 273 Kelvin here. What would be 100 degrees Celsius? Boiling water? At 100, it would be 373 Kelvin. Take a picture of this one or write that one down. If you guys can't see it, let me know. But you will need that there. Okay? You've got to be able to flip. Because all of these guys here, see that temperature there? It's no good in Celsius. You've got to flip it there to Kelvin before you do anything. And going back into this question here, again, I've given you moles, I've given you volume, I've given you temperature, which you have to change to Kelvin, and I've given you the R value. Now just be careful of the R value. It's another place to make a mistake here. All right? If you're using atmospheres for your pressure, okay, you have to use your R value will be 0.821. If you're using kilopascals for your pressure, you will use 8.31. That's how that one goes, okay? It's all written on your sheet, okay? It's all here, so you don't have to memorize it, but it is there. Just be aware of it, okay? So, and plugging and playing. That's all this is, calculator stuff. All right, so that's question 88. What's my answer? I've got an answer of D, 2.5 atmospheres. Okay, so what other questions do we have? Anyone, is it still blurry? Is it all right? Talk to me here. It might be blurry through your internet, but you may want to watch this again on YouTube because maybe it won't be blurry because it's my computer picking this up, so it might be actually very clear. What do you guys got? Talk to me. Another question. Anything? Oh, there we go. Which R value do we use? So we had a question there. Which R value do you use? Okay. Keep it simple. Okay. You can use, well, look at your answers. What are your answers for question 88? You see your answers there? Sorry, I don't know if you guys can see that. Have a look at question 88. Your answers are only in atmosphere. So that answers your question about which one you're going to use, because A, B, C, D is only in atmospheres. So use that question. Use that R value right there. Okay? So if the question's only in, the answer's only in atmospheres, then only use it there. Okay? Judge and play by whichever answers there you have. What else we got? Which R value? Well, talk to me. If you're confused, talk to me. What's confusing you? Talk to me. Yeah.
So, sorry, at the top, do you see where it says like T equals 20 degrees Celsius, and then so all of our knowns?
These are your knowns, yeah?
Yeah, so the very top one, it says MA, and I just can't read it, it's kind of blurry. It would say MAC squared.
Oh no, it says moles.
Okay.
Because your moles are given, right? That was right in the question. So there are your moles.
I thought so, but I thought you wrote differences.
No worries. No, thank you. That's it. That's great. So, you see, you're looking at this question, you're reading it, and you're going, okay, I think that there's gases going on here, but Ian gave me moles. Well, there's really only one formula there that integrates gases and moles, and that's PV is equal to nRT. So, okay. Good. What's another question there do you guys have? Or we could just try some. Question. Okay. Let's have a look at question 112. Question 112. So there it is right there. So what volume of dinitrogen pentoxide is produced when 500 milliliters of oxygen react completely in the following reaction at STP? Man, maybe before we do this one, maybe we should go back and do some week 1 stoichiometry. But maybe let's try it. So, you guys all have a picture of that somewhere. I'm going to take that off, and so I've got my question in front of me. What volume of dinitrogen? Okay, well, you know what? I'm going to write out the formula first, or the chemical equation here. Plus 5 oxygen produces 2 N2O. So there it is right there. Molar ratio.
Can you tilt it up a bit so we can see the equation, please?
There you go.
Thank you.
And we've got 2. So there's my molar ratio. So there we go. Now, what is it asking for? What volume of dinitrogen? So I'm looking for volume of N2O5. Okay, N2O5. So I'm looking for the volume here. I don't know what other information has it given me here. It's produced. So we're looking for this. So I got 500 milliliters is reacting here. I don't know what's going on here, because this kind of looks like we did stuff back at week 1, even last semester there in stoichiometry and chemistry 1008. Moles, moles, moles. I can't even do a box because this is in milliliters. I need moles here. How am I going to do this? The trick is you'll see that I told you it's at STP. Now, what does STP stand for? Standard temperature and pressure. So whenever you see STP, I didn't put it in there to confuse you. I put it in there because you need to do it. You need to use this. And whenever you see STP, it means 2 bananas. It means 2 pieces of information. It means your temperature is 0 degrees Celsius or 273 Kelvin. Okay? Same thing, but this is probably the one you're looking for. And your pressure will be 760 torr or 1 atmosphere or 101.3 kPa. Okay? That's what this means. And when you have gases at STP, remember, 1 mole of any gas at STP has a volume of 22.4 liters. Okay? So 1 mole of any gas at STP has 22.4 liters. So just by the way here, what would be the volume of 0.5 moles of a gas at STP? Well, this is half, so therefore this one here would be 11.2 liters. There's a ratio that we can use here between gases and moles. Okay, so, and I'm just going to put that 1 mole is equal to 22.4 liters. Okay, so, oh, my wife came back with the pooch. She just took the dog there to the vet, ripped off one of its nails, and I guess everything's okay. So, getting back to this. These are molar ratio. I need moles in here to do anything, because I'm going to have to do a box. Okay? But I can't do a box without, I need moles here. So, how do you do this? 1 mole is equal to 22.4 liters at STP. Well, I don't know how many moles of this is going to be, but I do know that I have half a liter of it. Because it says so. It told me. So now, you just cross multiply, and you get x is equal to, my calculator, 0.5 divided by 22.4. So, this right here is equal to 0.022 moles. So this is 0.022 moles. Okay? So now I can do a box. X. Which is just the same way as what we did there last 6 weeks ago, which seems like a million years ago. Told you, man, these semesters, man, they just motor. Okay? And you found your moles here. Now you do your box. There you go. You find your moles, and away you go. And I think the answer there for that one, we could keep going. So let me erase this and let's keep going. So what do we got here now? So you do a box. 2 is equal to 2. Whoa, you're going to have the same. I don't even need to do a box. Because, so my answer here will just be 0.022 moles. That's the answer there for here. What's the question asking? What volume? What volume of this? The answer is A, 500. Okay, so that's what you're looking for there. You're just going backwards there from what we just did. because you got moles here. Use the same formula. 1 mole is equal to 22.4 liters. Okay. Here I have 0.022 moles, and that'll give you 500 mils. No, it's okay. Just hold on a second here, guys. Yeah, actually, it's been an hour. Let's take 5 minutes. Go and get a coffee. Go and refresh. I'm going to stop the video, and because we're going to be here probably, I'm going to be here for another couple of hours anyway. So take 2 minutes and go and do what you need to do, and we'll be back here in a couple of minutes, okay? Thanks, guys. And